All right, are you ready? I'm going to talk to you about table G. Let's get started. Here's what it looks like. A lot of stuff going on, but we're going to break it into pieces and process it. Okay, so it shows solubility curves, all right? So a solubility curve is specific for a substance. So every single substance has a different solubility curve. This image that you see right here, this one, easy peasy, it's 1, okay? But if we look back at table G, you can see, oh my goodness, a whole bunch of substances, but each line is labeled. So this line right here is NH3's line. NH4's line is right here. So each substance has a specific line. Okay, let's see what else. So notice the x-axis. So right here is temperature. It's in degrees Celsius and the scale is 10. So every line indicates another 10 degrees Celsius. So when I'm reading this, if I find a number is directly between these two lines, it would be, for example, between 10 and 20, it would be 15. If it's less than halfway, but closer to 10, it might be 12 or 11 or 13. If it's closer to 20, but more than halfway, it would be like 17 or 18 or something. It's important when you're putting answers down. Okay, so there's our temperature scale. Now look at the y-axis over here. It has a lot written there. So look, first of all, it says it's solubility. Great. But then it says it's in grams of solute in 100 grams of water. So that means I can only use this graph when I have 100 grams of water. So what if I don't have 100 grams of water? I'll talk about that in a second. But up here, one last thing I want to point out. You see here it says standard pressure. So when I'm using this graph, I am assuming or being told that it is at standard pressure. So again, scale is important. This 100 grams of water is a unique feature of this particular reference table, okay? So if your solution has less than 100 grams of water or more than 100 grams of water, you have to adjust. You have to set up a ratio. What the heck do I mean? Well, I'm about to show you. Ready? If a solution contains 23 grams of solute in 100 grams of water, how many grams are needed in 150 grams of water? Okay, so let's think about it. I have 23 grams of solute and I have it in 100 grams of water. But I don't want to know that. I want to know what would I need if I had 150 grams of water. So do you see this ratio, how I set it up? This is what I was given, 23 grams in 100 grams of water, but I want to know this, okay? So how do I solve it? Cross multiply. So 23 grams of solute times 150 grams of water equals 100 grams of water times x. Now I want x by itself. How do I do that? Divide by 100 grams of water. But if I divide that side by 100 grams of water, I got to divide the other side by 100 grams of water. I get to cross out the grams of water on that side. On this side, I get to cross out 100 grams of water, so I'm left with x. So what am I left with? 23 grams of solute times 150 divided by 100. So you're going to do that math and get 3,450 divided by 100 and 34.5 grams of solute. So there you go. Now, this should make sense. If I had 23 grams in 100 grams, when I jump to 150, I should need more, right? So 23 to 34.5, okay, it's more. Now, if I doubled it, that would be 200 grams. So it should be less than double, and it is. So you should make sure your answer makes sense. Okay, we can find saturated, unsaturated, and supersaturated on table G. So remember, saturated means contains maximum solute. Unsaturated, I could still add more solute and it would dissolve. So if it's saturated and I add more solute and I stir it up, like the solute just settles at the bottom. Now, supersaturated, I can make a supersaturated solution, but it's unstable. okay? So what I'd have to do is heat it up, add more till it dissolves, and then let it cool, but let it cool slowly. And as the temperature lowers, it becomes super saturated, but it's unstable. So if I bump it, all the extra comes out. If I bump it, all the extra comes out. If I take a little crystal, drop it in, all the extra just drops out, okay? So if a solution is saturated when I'm looking at table G, it is on the line. That means at 90 degrees Celsius, I have 40 grams of solute. I match those points up and it went directly on the line. If a solution is unsaturated, so at 90 degrees Celsius, I have 30 grams of solute. That point, when I compare it to the line, is under. So it is unsaturated. Shocking, right? Unsaturated, under the line. Okay, so in reality here, I could add 10 more grams of solute to get saturated. All right, now what if it's over the line? Can you make a guess? Super saturated. Okay, so in this case, 90 degrees of Celsius and 50 grams is above this line, so it is super saturated. So I have 10 extra grams in solution. How did I get those 10 extra grams? Well, I heated it up for a little bit so I could dissolve some more and let it cool. So let's look at this all together. On the line, saturated. Above the line, super saturated. Under the line, unsaturated. So time for some examples. Are you ready? Okay, are you ready? Here's an example. Here's a question. According to table G, which substance forms an unsaturated solution when 80 grams of the substance are stirred into 100 grams of water at 10 degrees Celsius? Oh my goodness, a whole lot of information. Let's break it down. So we have to remember this: saturated, supersaturated, unsaturated. Ready? Okay, here's the question again. I have 80 grams. Remember, I'm at 100 grams of water, so at least I saved that step. I'm at 10 degrees Celsius, so I'm going to go across from 80, go up from 10. Now it says, which substance forms an unsaturated solution? What does that mean? Okay, so I'm looking at that point. I'm looking for that point where those two lines cross to be unsaturated. So this point is under what line? Well, let's look up from here. I'm looking for this point to be under a line. Well, I don't have a lot of options. Do you have an idea? Hopefully you saw it was that one. If not, pause and go back so you can look. Next question. At standard pressure, what is the temperature at which a saturated solution of NH4Cl has a concentration of 60 grams of NH4Cl, 100 grams of water? Okay, saturated, on the line. I have 100 grams of water. Baby step saved. So let's look, okay? So right there, 60 grams. But I want to know the temperature. So I'm going to go across from 60 grams and I'm going to find my substance, NH4Cl. Okay. Saturated means on the line. So I'm going to go down from where it crosses that particular line and look for that temperature. Okay. What's that temperature? It's about 66. Okay. After being thoroughly stirred at 10 degrees Celsius, which mixture is heterogeneous? Okay, what does that mean? Well, there's 25 grams. So you can see how they're all using 25 grams. And it already told me it was all at 10 degrees Celsius. Okay. So find the line for each of those compounds. So I'm going to do that. Okay. It's a little crowded, so let's zoom in. Okay, so here we go. I'm just going to go back to exactly where I was. The line for NaNO3 is kind of up off the chart. So now I have to think. That point right here, where those three cross. Let me show you right here. This point is under three of the lines. It's under this one, it's under this one, and it's under this one. That means when I compare this point to each of those lines, it is unsaturated. That means all of it dissolves, homogeneous. Above, that point is above this one right here, above KNO3. So that one is super saturated. That means not all of it dissolves. Heterogeneous. So yeah, there we go. All right, at standard pressure, which substance becomes less soluble in water as the temperature increases from 10 to 80? So let's look at it. So find the line for each compound. Which substance becomes less soluble? So if it's less soluble, the line has to be going down, the slope decreasing. So what do you notice? Which line becomes less soluble? Hopefully you realized it was this one. What is the total mass of KNO3 that must be dissolved in 50 grams of water? Okay, I got to do a little bit extra here, but let's get started. Okay, so let's see. I'm at 60 degrees Celsius. I know that. I know it's saturated, and that means on the line, and I know I have KNO3. So I can go across at 60 degrees Celsius to where the lines cross. And how many grams do you think this is? Well, about 106. But remember, 50 grams of water. So now what? Well, we have to do something about that. So I had 106 grams from the curve, but I know I don't have 100 grams of water. I only have 50. So I got to cross multiply, solve, and what do you get? 53. A saturated solution of NaNO3 is 60 degrees Celsius using 100 grams of water. As it is cooled to 10 degrees Celsius, it precipitates or settles out. The resulting solution is saturated. How many grams settled out? Okay, a lot going on. Let's look at it. Okay, ready? 60 degrees Celsius. I prepared a saturated solution. So saturated means on the line. I'm looking at NaNO3. So I go across about 126 grams. But it is cooled to 10 degrees Celsius. So I'm going to go to 10 degrees Celsius, go up, and it says the resulting solution is also saturated. So go across from there and read that. So how many grams do you think that is? About 80? Okay. So how many grams will settle out? If originally at saturated, it could hold 126 when it was at 60, but I cooled it to 10 and that's saturated again, but it can only hold 80. So how much stuff is going to be at the bottom? Well, I do 126 minus 80. And what would that be? Yeah, about 46. All right, so there's a whole bunch of different problems. That's Table G. I hope you learned something new.